Good morning, students. Good morning, all of you. Yes, let us start. Question number 6 and 7, they were difficult. Any problem in these two questions? Yeah, any problem? Please write question number. Question number 6 and 7. Any one of you? Okay, Shivam, you have a problem in question number 7. Are you okay with question number 6? Okay, if you are okay with question number 6, you must have calculated number of sides, and that is 5. N is 5 here. So what is n plus 1? That is 6. This is also given that sides being equal to that of the n-sided regular polygon. So by earlier calculation, I can say that this will be 42 mm. So it will be a hexagon with the side of 42 mm. Is it okay, Shiva? Now come to the calculation part. We want to calculate the area. See, now this side is 42 and this is a hexagon. We know in a hexagon, since this is a regular hexagon, that's why I can say this triangle will be an equilateral triangle. What is the area for equilateral triangle? The formula is root 3 by 4 into side square. Since we will get 6 such triangles, that's why I am multiplying this by 6. That's why the total area of the hexagon will be 6 into root 3 by 4 into 42 square. And this is the answer. Is it okay? If you have solved question number 5, 6 will be easier. Okay, now come to the next question. Yeah, question number 8, 10 and 11. Okay, Amrita. 8. X toffees can be distributed equally among Y children where X is greater than Y. What is the number of values that X can assume such that Y is greater than 1 and 2 is less than X plus Y is less than 110? See, what are the conditions given? X toffees. You are distributing these toffees equally among Y children. It means Y divides X. And Y is greater than 1. So Y will be greater than equal to 2. We can say that. Now taking another conditions. See, what are the other conditions? It says X toffees can be distributed equally among Y children. It means X is equal to Y into something. These are number of toffees and these are number of children. The next condition is Y greater than 1, so I can say Y is greater than equal to 2. Is it okay now? Okay, see, it says X toffees can be distributed equally among Y children. That's why X can be written as Y into something, where X stands for number of total toffees and Y stands for number of children. It is also given that Y is greater than 1. That's why Y should be greater than equal to 2. Y should be an integral value because Y is number of children. We cannot take fraction or decimal. This is also given that X plus Y is less than 110 and it should be greater than 2. Now see how many values we can take. This is also given that x is greater than y, or we can say x is not equal to y. Now how many values we can take? First of all, y should be a factor of x, and y shouldn't be equal to 1. Now how many values of x are possible? Maximum value of x can be, see, y is minimum 2, so x can be maximum, we can say 7, 107 I mean. Now if I take a random example, I am taking, suppose I am taking 23. X cannot be 23. Why so? Because y is a factor of x. Either y will be equal to 1 or 23. 1 is not allowed. Also y is not equal to x. That's why this is also not allowed. That's why x cannot take any prime value. X cannot take any prime value. Once again, I am taking one more example. Let it be 17. So y should be equal to either 1 or 17, because y should be a factor of x. Now y is not equal to 1, that is given. Y cannot be equal to 17 as well. Why? Because y is not equal to x. This is mentioned in the question. So y cannot take any prime value. Now our range is 1 to 110. If I consider all those numbers up to 110, I'll subtract all the primes value. How many primes are there till 110? You should remember that 1 to 100 there are 25 primes, and in the remaining range 101 to 110 there are 4 primes. They are 101, 103, 107 and 109. That's why I'll subtract these 29 values, as well as I am subtracting 1 as well. See, what is my question? X can assume how many values? We will subtract all the primes. We will subtract 1 corresponding to 1. We will subtract 2 as well. 2 we have subtracted already. Leave it. We cannot take 110 as well. Why so? Because if I take x is 110, there will be no possible value of y. So corresponding to that, I am subtracting 1. And 108 is also not possible. Why so? See, if I take, my condition is, if I take x as 108, y will be 1 in that case. That is the only possibility I can take, but this is not possible. So corresponding to 108, I am subtracting one more 1. That's why we are left with these many choices. So this is the answer. Is it okay? Amrita and Nishchay? Okay. Now question number 10 or 11. Any problem? Okay, Swar. See. What are the conditions given? X, Y, Z are positive numbers. And the first condition is given as greatest integer of X, fractional part value Y, and gent of Z, that is 11.2. Gent is always integral value. This is integer, Z is also integer. Of course, sum of two integers will be integer always. That's why Y will be a fractional value. That's why I can say that fractional part or decimal part of Y will be 0.2. Now I'm taking the another condition, the next thing. That is also given as 10.3. So with the same logic, I can say fractional part of Z will be 0.3. And by using the third condition, similarly, I can say that fractional part of X will be 0.4. So we know fractional part of X, Y and Z. If we add all these, three equations mentioned in the question. If I add those, I'll get twice of gent of x plus gent of y plus gent of z plus fractional part of x plus fractional part of y plus fractional part of z. That will be equal to 11.2 plus 10.3 plus 9.4. It will be 30.7. Can I say that? Is it okay with you, all of you? Since we know the values, so I can say simply that leaving the fractional parts, I can say this will be equal to 30. So what will be the value of this? Sorry, 30.9. What will be the value of the gent part? It will be 15. 2 into 15 is equal to 30. Now you can solve it. I think this is easy now. Is it okay, Swar? I'm leaving it here. Thank you, Shivam and Arnab. Yes, I'm coming to that. Question number 11. If A, B, C, D are four distinct natural numbers, each of which has exactly 5 factors, find the number of factors of the product of A, B, C, D. A very good question on factor theory. If you know factors theory, you can solve many questions in number system. Before explaining this question, let's have one more question. Randomly, I'm writing any number. Let it be 2 cube 3 raised to power 5, 5 square into 7 raised to power 1. Okay, you solve these many parts. First of all, you will find how many number of factors are possible. Second, please give me the answers. Write the answers in the chat box. Number of factors. Then you will find number of even factors. Then you will find number of odd factors. Then you will find number of factors which are ending with 0. I'll explain each and every part. Then you will explain number of factors which are perfect squares. I think these many parts are sufficient to explain the factor theory. Okay, odd are 36, even are 4. Amrita, no, of course this is not the answer. Even multiplied by anything is always even. So how can you neglect 2 into 3, 2 into 3 square and so on? Okay, let us see. Even 4. Okay, what about question number 4? Number of factors ending with a 0. One more part I want to write. Number of factors which are ending in 5. Yeah. I'll come to question Navi. Before explaining that question, I want to explain the factor theory. Order 36. I'm waiting for 4th, 5th, 6th part. Ending in 0, 2. Okay. No, Shivam, this is not the answer. Let us see. First of all, I'm explaining the basic part. This is my number. I want to go into factors. I'm taking the very first part. That was a basic thing. See, factor is a thing which divides the number completely. So, 2 raised to power 0, 2 raised to power 1, 2 square, 2 cube. These many factors we can take for 2 cube. For 3, we can take 3 raised to power 0, 1, 2 and 3 raised to power 5. For 5, it will be 5 raised to power 0, 1, 2, since we should be in factors only. So these many permissible powers are there. Are you getting me or not? Now I'm taking the very first part. I want to take a factor. Yes, from powers of 2, how many choices can be made? It will be 4. 3 plus 1 I am taking. From powers of 3, how many choices are possible? They are 6. From powers of 5, how many choices are possible? They are 3. And from powers of 7, it will be 2. So what is the answer to the very first question? It will be 4 plus 6 plus 4 into 6 into 3 into 2. You can see the this formula in many books. This is the logic. That is a simple case of choices. Why we add 1 here? Corresponding to 0. That's why. Yeah, 4 into 6 into 3 into 2. That is the answer for very first part. If you got this question, now it will be easy. Now come to number of even factors. What do you mean by even numbers? The numbers which are divisible by, exactly divisible by 2, they are known to be even numbers. Now, this power will not be allowed. Why so? This is not a permissible power. Why so? Because if we take 2 raised to power 0, it will be simply 1. It means 2 is not here, but to make an even number, we need 1, 2. That's why, what is the answer? It will be from powers of 2, I can make 3 choices, and we don't have any problem if any other number comes with at least 1, 2, it will be an even number only. So it will be 3 into 6 into 3 into 2. Is it okay, all of you? 3 into 6 into 3 into 2. I'm not going into calculation. I'm just writing the expression. Now come to odd factors, number of odd factors. We can do two things. Either we can go directly, or we can do the number of factors minus total number of even factors. We will be left with odd factors only. But if we go directly, see, in case of number of odd factors, what do you mean by odd factor? It means that any number which is not divisible by 2, or plainly we can say there shouldn't be any 2 in prime factorization of that number. That's why this column will not be allowed in case of odd factors. That's why we will be left with 6 into 3 into 2. That is the answer in number of odd factors. Is it okay, all of you? Yes, now come to number of factors ending with 0. Now we want to find number of factors ending with 0. If any number which is ending in 0, of course that should be a multiple of 10. Then only any number can end in 0. It means we are looking for all the factors which are multiples of 10. To make a 10, I need 1 5 and 1 2. That's why we will take all those factors, all those permissible powers in which at least 1 5 is present and at least 1 2 is present. That's why these two powers are not allowed. Other things are allowed. So what is the answer in this case? It will be 3 into 6 into 2 into 2. We will leave 2 raised to power 0 and 5 raised to power 0, because in that case it will not be a factor of 10, multiple of 10. That's why this is the answer. Is it okay? Should I move further? Okay. Now come to question number 5. Number of factors which are perfect squares. See, what do you mean by a perfect square? For example, 2 square. We can say that 2 square is a perfect square, but 2 cube is not a perfect square. So, if we write prime factorization of any number, and if this is a perfect square, the powers should be even always. That's why we will not consider this power, 2 raised to power 1, 2 cube. These are not permissible powers. 3 raised to power 1 we will not take. 3 raised to power 3 we will not take. 3 raised to power 5 we will not take. So I can say 2 raised to power 0 is allowed. 2 square is allowed. 3 raised to power 0 is allowed. 3 square, 3 raised to power 4. Similarly 5 raised to power 0, 5 square and 7 raised to power 0. Or I can say if I take any combination of these numbers, I'll get a perfect square which will be a factor of original n. So how many perfect squares are possible? It will be 2 into 3 into 2 into 1. I think you are okay with the concept. Why am I multiplying here? Yes, yes. Now come to the next part, the last one, that is the number of factors ending in a 5. Yeah, now anyone? What should be the answer for this? Number of factors ending in 5. Anyone? Please give me the expression. No, Naveen, this is not the answer. No. 2 shouldn't come, Arpit. Very good. So this column is neglected. Why so? Because if we multiply any 5 with a 2, it will end in 0. And we don't want a 0. We need 5 in the end. That's why what should be the answer? We don't have any problem with 3. 6 into 2 into 2. Shivam, absolutely this is the answer. Why? 5 raised to power 0 is not allowed, of course. Any number which is ending in 5, of course, should be a multiple of 5. That's why we have to take at least one 5 in that. We will not take any 2 because if we multiply any 5 with any 2, it will end in a 0. It will result in 10. That's why. That's why this is the answer. I think you are comfortable now in factors. Now come to the question. It says if A, B, C, D are 4 distinct natural numbers, each of which has exactly 5 factors. Of course, if any number has 5 factors, of course that should be in the form of P raised to power 4, where P is a prime. If I write prime factorization of A, it will be P raised to power 4. And all the numbers are distinct, that's why I am taking different primes. Q raised to power 4. Let it be R raised to power 4 and D is equal to S raised to power 4. Shivam, absolutely 625. Now, it says find the number of factors of the product of ABCD. Since all the primes are distinct, that's why what will be the product thing? It will be P raised to power 4, Q raised to power 4, R raised to power 4 and S raised to power 4. Now you can apply the number of factors formula. It will be 4 plus 1, 4 plus 1, 4 plus 1, 4 plus 1. That's why what will be the answer in that case? 625. That is the answer for this question. Is it okay, all of you? Now? Yes. Okay, I am making a little change in this question. Question number 11. Then you please tell me the answer. Let, instead of this 5, there is a 6. Now what should be the answer? Amrita, okay, please write your doubt. Instead of this 5, suppose in my question we have 6, then what should be the answer? Okay, Naveen. You said 625 into 25. Can you tell me the logic? Suppose any number is having 6 factors. See, 6 can be written as either 6 or 2 into 3. So, my number can be either P raised to power 5 or it can be P into Q square as well. P into Q square. Amrita, I am coming to your doubt. First of all, let me explain this. So, we cannot judge what will be the formation of A. Yes, of course. P and Q, they can be anything. P square Q as well. So, what should be the answer in that case? It will be cannot be determined. Because in the very first, we can have various combinations. That's why. In case of 6 factors, what will be the answer? Cannot be determined. Now coming to Amrita's doubt. Amrita, please write your doubt here. See, it says A is having 5 factors. Since 5 cannot be broken in 2 parts, 5 is 5 only. The maximum we can write 5 into 1. 5 is a prime number. So, we can say that there will be only one possibility for A, that will be P raised to power 4, where P is a prime. And It is saying that A, B, C, D, they are distinct natural numbers. That's why the remaining numbers will be in the same formation but with the different primes. That's why A will be P raised to power 4, B will be Q raised to power 4, C is equal to R raised to power 4, D it will be S raised to power 4. Amrita, A cannot be equal to PQ. Why so? Because in that case number of factors will be 4, which is obviously not possible in this case. Okay, I'm leaving this question now. Now come to this question 17 to 19. Maximum number of factors in question. Arpit, you make any question, I'll answer. You give me any expression. Of course, you cannot find maximum number of factors. For any number, if you know a number, we can determine how many factors are there. We have a formula for that. Of course, Arpit, if in previous question, there is a, yes, in previous question, if there is a question that find the maximum number of factors, then we can answer that, of course, because we will get many answers. Yes, of course. Amrita, we will try various combinations. We have two formations. Either A can be P into Q square or A can be P raised to power 5 as well. We will try all the various combinations. Then we will select the maximum thing. Okay. Now question number 17 to 19. If you have any problem in these three questions, please write the question number, because that was a complete set. Whenever you come for analysis session, please make it sure you go through the paper. Amrita, have you read the whole story? The question seems difficult, but if you read the whole story thoroughly, you can answer every question. See, it says there are two airports. One is Kingstown Airport. One is QCAP Queen City Airport. The distance between them is 800 kilometers. There are some two trade centers, and there are two planes. One is jet plane and one is Boeing 642. Now it says nearly 20,000 people had trickled into the office at 9 a.m. when the plane crashed into the first building. It means jet will hit the first building at 9 a.m. While 23 minutes later, the second plane, what appeared to be Boeing 642, flew into belly of the second building. It means Boeing 642 is hitting the building at 9:23 after 23 minutes. Now it says when the jet plane had crashed into the first building, at that time, I mean at 9 a.m., the Boeing 642 was flying 8,000 meters, that is 8 kilometers, from QCAP and was flying away from it towards this. So there will be a plane, Boeing 642. There will be a plane, Boeing 642. At what time? At 9. And in 23 minutes, it is reaching its destination. In 23 minutes, it's reaching its destination. And this distance is 8 kilometers. And then there is a story of ambulance. The ambulance of Health Plus Hospital, which is just near the QCAP, had reached at 11 a.m., which was sent from the hospital after 20 minutes of the accident of the first plane with an average speed of 60 km per hour. Now, ambulance started at 9:20. and reaching at 11. It means ambulance is taking in total 100 minutes. Are you getting me, Amrita? And in 100 minutes, it is moving with a speed of 60 km per hour. In 100 minutes, it means it will cover 100 kilometers. It means the distance between the destination and the airport will be 100 kilometers. Now, Boeing Boeing has left 8 kilometers and is covering the remaining distance. And what is the remaining distance? It will be 92 kilometers. The whole patch was 100 kilometers. The Boeing was 8 kilometers away from the QCAP, Queen City Airport. That's why it will cover 92 kilometers in 23 minutes. So what will be Boeing speed? It will be, if in 23 minutes it is covering 92 kilometers, in 60 minutes, of course, it will cover how many kilometers? It will be 4 times only. It will be 240 kilometers. So what will be the Boeing speed? That is 240 kilometers per hour. That was one of the question. Since we know the Boeing speed, now we can do anything in this question. Is it okay, Amrita? That was a complete story. But the questions were easier. Okay. Now come to question number 26. I'm leaving 17, 18 and 19. Now all the questions are solvable. Yeah, any problem in 26? Permutation and combination. I'll rate it as a difficult question. If you know the concept, of course, you can answer this. But you should be very comfortable in permutation and combination. Difficult topic. Yes, sir. Okay. Anybody else? 26. Yes, Shivam. See, before explaining this question, let me take a concept. Suppose you have 10 distinct balls, distinct as in, suppose they are of different colors. You want to make 2 groups out of them. One is of 6 balls, one is of 4 balls. In how many ways can it be done? Yeah, any one of you. Yes, either you say 10C4 or you say 10C6. Yes, Shubham and Shashwat. Of course, you'll get the same answer. What is the concept behind that? I'm considering that you know the meaning of NCR. NCR is what? If you have n distinct things and you want to choose R out of them, it can be done in NCR ways. What is the value for this is? N factorial divided by R factorial, n minus R factorial. Now come to this case. It will be, we are choosing any 6 balls out of these 10. Of course, we'll be left with 4 balls. So whether we write it or not, we'll get the same answer, of course. 10C6 into 4C4. So what will be the answer? It will be 10 factorial divided by 6 factorial, 4 factorial. That is the answer to this question. I'm taking one more example. Let it be 10 to, say, let it be 3 and 5. You have again 10 distinct balls and you want to make it, you want to make 3 groups out of that. One is of 2 balls, one is of 3 balls, one is of 5 balls. What should be the answer now? 10C2 into 10C3. No, Shashwat. Please correct the second expression. It should be 8C3. Because you are left with 8 balls. Yes, of course. So, it will be 10C2. Out of these 10, you are selecting any 2 and you are making a group of that. You are left with 8 balls. You are selecting any 3 and you are left with 5C5 and we want to choose 5 out of them. So, if we take this, it will be this thing. So, what should be the answer of this? It will be this. Now, I'm taking one more example. Suppose my question is this. Now, what should be the answer? Here is the problem. Now, what should be the answer? Yes, any one of you? Yes, 10C2 into what's what? Shubham, why you are dividing it by 2 factorial? Very good, Shashwat. Exactly, Shubham, because there are 2 groups of equal formation. That's why we are dividing by 2. So my answer will be not this, rather this. See what is the logic now. Yes, Amrita. What is the logic? Suppose I have 4 balls named A, B, C, D. I want to make group of 2 each. 2 groups of 2 each. I'm taking a smaller example. So apparently my answer should be this 4C2 into 2C2. But what is the value? This is 6. What do you mean by 4C2? That is, you are selecting any 2 out of these 4 distinct things. So I'm making a group of 2. Suppose I'm selecting AB. So you are left with CD. That is the one way. Another way is AC. You are left with BD. In third, you are taking AD. You are left with BC. In fourth, you are selecting BC. You are left with AD. I'm taking any 2 out of these 4. I'm taking all the exhaustive cases. BD, AC. 6. Then we are left with CD, AB. But if we are selecting any 2 out of these 4, first and the last thing, that will be same. Second and second last, they are same. Third and third last, they are same. That's why there will not be 6 cases, rather 6 by 2 cases, that is 3. What should be the answer in that case? 3 will be the answer. You got this concept? All of you? Now coming back to question. What was the question? So I'm summarizing this. What is the thing? You know the concept now. I'm writing only the solution. What should be the answer in that case? It will be 10 factorial by 6 factorial, 4 factorial. It will be 10 factorial divided by 2 factorial, 3 factorial, 5 factorial. But in case of equal formation, it will be 10 factorial divided by 2 factorial, 4 factorial, 4 factorial done into how many repetitions are there? 2. 4 is appearing twice. That's why we are dividing it by 2 factorial. I'm taking one more example. Let it be 10. Say 1, 1, 4, 4. So it will be 10 factorial, 1 factorial, 1 factorial, 4 factorial, 4 factorial. Will divide it by 2 factorial, 2 factorial. Why so? Because 1 is appearing twice, 4 is appearing twice. That is the crux of the story. Now coming back to question. My question was, if n is the number of ways of dividing 500 students into 5 sections of 100 students each, how many zeros does n end with? I think this part is manageable for you. How many zeros does n end with? I'm taking the concept only. There are 500 students. You want to take 5 sections of 100 each. That's why how many sections are possible? It will be 500 factorial divided by 100 factorial raised to power 5 divided by 5 factorial. Because sections have different identity, we can take, it will be section 1, section 2, section 3. Since sections are distinct, that's why I'll multiply this with 5. That's why we are left with this expression. Now the rest of the thing is manageable for you. Is it okay, all of you? Naveen, if you have any problem, please write it. Sections are always distinct. We can say that this is section 1, section 2. Had the word be group, had it been this word group, then the answer will be 500 factorial, 100 raised to power 5, 5 factorial. In case of group, we can say groups are not distinct. But in case of sections, Of course, in a class, we can say this is first section, A section, B section, C section. That's why sections are always distinct. So these many groups are possible, but if you want to name them, they can be named in 5 factorial ways. That's why I'm multiplying this by 5 factorial. Is it okay now, Navi? I'm waiting for your answer. Okay. How many zeros? Amrita, that is a very, very basic concept. I'll give you 5 minutes after this session. Now come to 27th and 31. 27th, Abhishek. Okay. Sheila was presented with a cake and she wants to obtain the maximum number of pieces with a certain number of straight line slices. Formula based question only. Suppose there is a cake. Suppose we are taking only one line. If we are taking only one line, I'm writing pieces here. If we are taking only one line, how many pieces are there? 2. Here, if we are taking one more line, there will be how many pieces? 4. I'm trying to generate a formula. If we take third line and we want maximum number of pieces, of course we will not use the old intersection point. It will reduce your slices. Now how many pieces are possible? 1, 2, 3, 4, 5, 6, 7. So in case of 3, there are 7 pieces. Now you can go by generalization. So simply you should remember this formula. Whenever you are taking n lines, you will get 1 plus sigma n pieces. That is the maximum number of slices we can take. Since 2 can be written as 1 plus 1, it can be written as 1 plus 1 plus 2, it can be written as 1 plus 1 plus 2 plus 3. That's why we have derived a formula. It will be 1 plus sigma n. You know the value of sigma n. This is n into n plus 1 divided by 2. Now question says you have made 8 lines. That's why how many pieces are possible? It will be 1 plus sigma 8. I think, Abhishek, is it okay? Okay, let us move to next question. Yeah, 31st. Any problem in this? Good question of algebra. Answer is not first or second option. Yes, Shubham. You can interpret that by taking the diagram. Yeah, any problem in question number 31st? Okay, Gaurav. See, it's a very, very easy question if you read it thoroughly and you know basic algebra. A curve follows a cubic equation this, and another curve is to be formed with a1 is equal to 1. We are taking this coefficient as 1 in the second equation. Also, two roots of both the cubic equation have the same magnitude and sign, while the unequal root of the second equation is twice the unequal root of the first equation. I'm going by putting values. Let the roots of the first equation are 1, 1 and 2. Now, the another equation will be 1, 1 and 4. If I make first equation, it will be x minus 1, x minus 1, x minus 2 equals to 0. I can multiply this number by anything. Let it be a1. a1 can be anything. Of course, a1 can be 1, a1 can be any non-zero value. It will give you the same root, and the roots will be 1, 1 and 2. Now, in the second equation, a1 is 1. It means coefficient of x cube is 1. So, my equation will definitely be x minus 1 into x minus 1 into x minus 4 is equal to 0. Are you okay with this? Because that was the crux of the whole story. That was the problematic part. Okay. Now, what is the question? Percentage change in the constant term. What is the constant term of first? That will be minus 2a1. You can multiply those. What will be the constant term of second? That is minus 4. We cannot calculate any percentage change because a1's value is indeterminate. That's why what should be the answer? It should be cannot be determined, not first or second option, because a1 is not known. That's why. Is it okay, all of you? Okay. Now the next thing. We don't have any question for this 36 to 40. I think there is a problem in PPT. I'm leaving this once. Okay. Question number 42, 44 and 45. Any problem? Good lot it was. Number system only. 42, 44 and 45. Please write down question number. Yes, sir, it was difficult. Actually, calculation was difficult. Otherwise, set was easy. 42. Okay, Shashwat. See, I'll explain each and every question. 42, 44 and 45. First of all, I am taking 42nd question. It says 3 raised to power 100, 3 raised to power 200, 3 raised to power 300, so on up to 3 raised to power 10,000. When divided by 26, what is the remainder? First of all, how many terms are there? There are 100. You are starting with 1 into 100. You are ending in 100 into 100. That's why there are 100 terms. Now there can be numerous things. You can go by cyclicity. You can go by Euler number as well. Whichever you are comfortable in. I'm using Euler number. What is Euler number? Suppose I am taking 3 raised to power n divided by 26. Since 3 and 26, they are co-prime to each other. See, what is a Euler number first of all? If there is a number, say a, and you are dividing it by n, a raised to power Euler number of n, when divided by n, what will be the remainder? That is 1 always. I mean to say, a raised to power Euler of n, when divided by n, remainder will be 1 always. But there is a little condition. What is that? A and n, they should be co-prime to each other always. Are you okay with this? Co-prime to each other. How can we calculate Euler number? Any one of you? Let my number be, I'm writing the prime factorization. What is the Euler number of n? That is you will get a tutorial on Euler number on your mobile application. You should download the Bullseye app. That is the Euler number of n. So, if a and n, a raised to power en, when divided by n, that will leave remainder of n, provided a and n, that is the important thing, they should be co-prime to each other. Now I'm coming to this question. See, I'm taking 3 raised to power n divided by 26. N can take any value, 100, 200, so on up to 10,000. Now, what is the Euler number of 26? I'm writing the prime factorization, that is 13 into 2. What is Euler number of 26? That will be 26 into 1 minus 1 by 13, 1 minus 1 by 2. 26 into 12 by 13 into half. That will be 12 only. So, Euler number of 26 is 12. Euler number is nothing but cyclicity. I can say it will give you cyclicity directly. We need not to calculate this. So I can say that 3 raised to power 12 when divided by 26, remainder will be 1 always. Now I'm using this thing in the original expression. Now 3 raised to power 100 when divided by 26. We know there is a cyclicity of 12. It means at every 12th place we are getting a remainder of 1. Now 3 raised to power 100 can be written as 3 raised to power 96 into 3 raised to power 4. That is 3 raised to power 12 into 8 into 3 raised to power 4, that is 81 divided by 26. So remainder of this will be 1 always. Yes, I'm coming to that. You could go by cyclicity, Amrita. So what is the remainder? 4 will be the remainder in this case. If you know the concept of Euler number, no need to write the whole cyclicity thing. Now 3 raised to power 200, if 3 raised to power 100 is leaving a remainder of 4, what will be 3 raised to power 200? That will be nothing but square of the previous thing, so it will be 4 square. 3 raised to power 300, it will be 4 cube, and so on. Now you can calculate it. I think this is manageable now. Is it okay? Okay, so I'm leaving this. Shashwat, is it okay with you? That was your problem, I think. Okay. Yeah, question number 44. Given this, where x and y are positive integer less than 100, how many distinct pairs of x and y exist which will satisfy the given equation? See, first of all, I'm taking this expression. It will be nothing but this thing. I'm trying to make factors. That is a basic thing only. So 5x is common. We are left with 3x minus 2y. Similarly, 4y is common. We are left with 3x minus 2y once again. So my factors will be 5x minus 4y into 3x minus 2y is equal to 0. Product of any two things is 0. It can be possible only if we are getting one factor as the 0. So either 5x minus 4y will be equal to 0 or the other thing. I'm explaining only one thing. So I can take x by y as what? 4 by 5. Now we need to know how many distinct pairs of x and y exist which will satisfy the given equation. There is one more condition given, that x and y are positive integers less than 100. We know the ratio now. So x and y, they can be 4 and 5. They can be multiple of those because the ratio should be 4:5. Swar, is there any problem? Other thing should be 8, 10. Another thing will be thrice of 4 and 5, that will be 12, 15. We can go up to, see, the condition is less than 100. So we can go up to 19 times. It will give you 95 and 76. So these 19 values are possible. Similarly, we will calculate for the other expression, that is 3x minus 2y. Is it okay? Then we will calculate this. Is it okay, all of you? Gaurav, it was your problem. 44th question. Okay. Now the 45th sum. 45th, good one. Nice concept of Euler number. Question number 45. Yes, of course, sir, I'm doing that. See. First of all, what is the 45th question statement? The sum of two numbers is 4732 and then HCF is 13. If HCF of two numbers is 13, what is this word? This is factor. It means 13 is a factor of x and y. That's why x can be written as 13 into something and y can be written as 13 into something. Where a and b, they should be co-prime to each other. Why so? See, it says highest common factor should be 13. It means except 13, there will not be any number which is shared between x and y. That's why a and b, they will not share anything except 1. That's why a and b, they should be co-prime to each other. That was the thing in this question. Now addition is given. It will be 4732. A plus B. It will be 4732 divided by 13. We are left with this thing now. Now I'm taking a smaller example to explain this concept. Had the value been small, let it be say 5. So we want to calculate how many such pairs of A and B are possible where sum is 5, or I can take 15 as well. 15 I'm taking, and A and B, that should be co-prime to each other. See what is the thing now. See, it says A plus B is equal to 15. Now it can be 1 plus 14. It can be 2, 3, 4, so on up to 15, 13, 14, 15. Sorry, 1, 2, it will be 13, it will be 12, it will be 11, and so on. Now A and B, they should be co-prime to each other. That's why this is not allowed. 3 plus 4, 3 plus 12, that is not allowed. Now we can take Euler number of 15. What is Euler number of 15 if we count it directly? 15 is 3 into 5. So you can apply that formula we have discussed. So it will be 2 into 4, that is 8. What do you mean by Euler number actually? That is the number of numbers which are co-prime to 15. They are 1, 2, 3 we will not take, 4, 5 is not allowed, 6 is not allowed, 7, 8, 9 is not allowed, 10 is not allowed, 11 we can take, 12 is not allowed, 13 we can take, 14 we can take. Now you can make it 1 and 14, the first number and the last number, they add up to 15. Second and the second last number, they add up to 15. Third and the third last number, they add up to 15. 7 and 8, they add up to 15. So these many pairs are allowed. So what is the 15's Euler number? That is 8. Are you getting me, guys? I'm not going into very basic thing. You should know the meaning of Euler number. Then only you can understand this. What is 15's Euler number? It will be 8. So if 8 numbers are there, how many pairs can be made? They are 4. That's why we will calculate Euler number of the expression. Then we will divide it by 2. And that is the answer in this case. Is it okay? All of you? Yes, it's a nice concept, Shashwat. There is one more question if you are okay with this. Okay. We are getting the value as by solving this, it will be 364, I think. So we will calculate the Euler number of 364. That comes out to be 144. So what will be the answer? That is 72 in this case. There is one more question I am taking. We know Euler number of 364, that is 144. What is the sum of all those numbers less than equal to 364 and which are co-prime to 364? Yeah, any one of you. Abhishek, actually that was the concept. A and B, they will be co-prime to each other as well as they'll be co-prime to 15 as well. Yes, any one of you? Yeah, any one of you answer for this? I think all of you are not comfortable in Euler number. Let me take a good time to explain this concept. Okay, let us start. Let my number be 24. Now we will calculate how many numbers are there, natural numbers I am talking about, numbers are there which are co-prime to 24. You must know the definition of co-prime. co-prime to 24 and they are less than equal to 24. Listen it carefully. Important concept of number system. Applicable in remainder question 2. What do you mean by co-prime? We are looking for actually all those numbers whose HCF with n is 1. I mean with 24 this is 1, and all these a's should be less than equal to 24. We are looking for all those numbers which are less than equal to 24 and they are co-prime to 24. Now, what is 24? That is 2 cube into 3. 8 into 3, I mean 2 cube into 3. I'm writing the prime factorization here. If I want prime, co-prime thing, I mean HCF is 1, A should not include any 2 or any 3. A should be independent of 2 and independent of 3 as well. Is it okay? Now, if A should be independent of 2 as well as independent of 3, it means A should be 1 to 24, all those numbers which are neither divisible by 2 nor divisible by 3. We are looking for all those numbers which are not sharing any factor with 24 except 1. Since 24 is 2 cube into 3, it means A should not include any factor as 2 or 3. It means what? We are looking for all those numbers from 1 to 24 which are neither divisible by 2 nor divisible by 3. Is it okay with you, all of you? Now, 1 to 24, how many numbers are there? 24. Can you say every second number will be a multiple of 2? It means exactly half of the numbers are there which are exactly divisible by 2. So we are left with the remaining half. Similarly, every third number is divisible by 3. That's why 1/3 of the total numbers will be divisible by 3. It means remaining thing will not be divisible by 3. So it will be half 2 by 3. It means there are 8 numbers. There are 8 numbers which will not be, which are co-prime to 24 and they are 1, 23. 2 we cannot take, 3 we cannot take, 4 made of 2 we cannot take, 5 we can take. Corresponding to 5 there will be a 19. See, I'm making a sum of 24. Then we cannot take 6, we can take 7. It will be 17. Again I'm getting a sum of 24. 8 is not allowed, 9 is not allowed, 10 is not allowed, 11 is allowed. Again a sum of 24. These 8 numbers are those numbers which are co-prime to 24 and less than equal to 24. Actually, number of these numbers, yes, 6 we cannot take because HCF of 6 and 24 will be 6 and we need 1 as the HCF. Is it okay, Arpit? We need HCF as 1. No, I'm not counting here. No, 6 is not written in this. These 8 numbers are allowed. 1, 23, 5, 19, 7, 17, 11, 13. I'm not going to write 6. Okay. Now, number of such numbers are 8. And this is called, number of such numbers is called Euler number of 24. So what is the Euler number of 24? That is 8. What do you mean by Euler number of 24? Number of those numbers which are less than equal to 24 but are co-prime to 24. And they are 8. That is a derivation of this formula. That is the logic behind that. Why are we using n into 1 minus 1 upon p, 1 minus 1 upon q and so on. Now my next question was, what is the sum of all such numbers? Can you say every pair is making number itself? So I'm writing the formula only. That is the sum of all such numbers. We are getting the same number, but how many times? Euler number of n divided by 2. Is it okay, all of you? Good application in remainders. Arpit, no, Euler number is not numbers which are co-prime. Euler number is number of such numbers which are co-prime to the 24. Since we are getting 8 numbers here, that's why Euler number of 24 is 8. How many such numbers are possible? That was the thing. Okay, let us move. Yeah, now I think that is okay with you. Question number 47 to 50. According to me, it was easy set, but according to your data, this is difficult. Any problem in these questions? 47 to 50. Good. Simple, very simple calculation it was. Okay, 47, 48, 49 and 50. Easy questions they were. I'm leaving those. Now come to this, 55 to 58. Easy, yes, of course, were. If you are comfortable in making Venn diagrams of 3 variables, then this will be an easy set. Yeah, any problem? If you want me to explain any question, please write down the question number from 55 to 58. That will be a one-go set. Okay. I think all of you are okay with this. 55th. What is the minimum number of candidates who had at least 2 of 3 attributes? Okay. First of all, yes, I'll come to that, sir. Okay. See, Arpit, I'll make a Venn diagram. There are 3 attributes. One is tall, handsome, and dark. The first condition says tall and handsome but not dark. It means this is 9. Then the next attribute is dark and handsome but not tall. Dark and handsome but not tall. It means this is 12. This is 9. Now next is tall or dark but not handsome. This is the keyword here. Or there is one more thing. The agency could find only one person who satisfies its criteria. It means the intersection of 3 will be 1. You must have read the whole set. Now, what is the meaning of this third condition? Tall or dark. Let it be A, let it be B, let it be C. It means by this condition I can say A plus B plus C, that should be equal to 107. And there is one more condition. Each candidate had at least one of the 3 attributes. That's why what will be the this remaining thing? It will be 150 minus A plus B plus C plus 9 plus 1 plus 12. So it comes out to be, I think, 21. Since we know this value, this is 107. Are you comfortable, Arpit, with these calculations? Now, okay, now what was the first question, 55th? What is the minimum number of candidates who had at least 2 of these 3 attributes? We want to minimize something. What is that? That is at least 2 of the 3 attributes. It means these 4 things. 9 plus 1 plus 12 plus A. B, sorry. We want to minimize this expression. These are the constant values. So I cannot minimize this. But this is a variable value, B. We can minimize this. Now, A plus B plus C, that should be equal to 107. If we want to minimize B, we will maximize A and C. There is one more condition given, the last lines. It was also found that for any attribute, the number of candidates who had that attribute alone didn't exceed 1/3 of the total number of candidates called. How many total number of candidates were there? 150. 1/3 of that is 50. It means A can maximum 50. C can be 50. So if A can be 50, C can be 50, we are taking the maximum value. B is left with 7. So what can be the B's minimum value? It will be 7. So what should be the answer for 55th question? That will be 29. That is none of these. Is it okay, Arpit? Okay. Rest of the questions were similar. Either you have to minimize or maximize something. The same concept we will apply. Okay, let us move. Yeah, come to this is for your problem, I think. Yes, football set. Yeah, any problem in this? Swar, can you write your problem here? Okay, what is the concept? Okay, you have PDF copy with you. Please open that because I need a new page to explain this set. Okay, since there is an arrangement thing also, and we are talking about left to right arrangement, that's why I'm putting name here. I'm putting jersey name and I'm putting color here, since we are talking about left to right thing. Now I'm taking that statement first in which some arrangement is mentioned. It says it was the very first, no, immediately won by Kaka. Yes, sixth one, the red jersey which is ahead of 3 other jerseys is worn by Kaka. The red jersey which is ahead of 3 other jerseys, in total there were 1, 2, 3, 4, 5 jerseys. So this thing is not needed. Okay, ahead of 3 jerseys, this is Kaka and its color is red. The red jersey which is ahead of 3 other jerseys is worn by Kaka. Okay, then second, Kaka is not wearing Chelsea jersey. It means we cannot take Chelsea here. And he is behind Messi. So first should be Messi. Are you getting this one? No, this is not so much data, Swar. There are only 3 variables. You can see many sets in AR, in CAT, where there are 6 variables. You just make a table and write everything. Abhishek, first of all, you take that statement in which some arrangement is mentioned. That's why I have taken 6th thing. Because in that case, Kaka's seat is determined. Is it okay now? Okay. Should I solve this set? Or you are okay with this? I think now this is solvable. You know the position of 2 players. Okay. I'm leaving this. Okay. Please tell 50 seconds. Okay guys, that's it for today. I'm coming to Amrita's doubt. That is 52nd question. A weird question, weird names. Okay. It says there are 3 persons. Say Appa, Chappa and Tappa. I'm taking initials. A for Appa, C for Chappa and T for Tappa. They are ordering either tea or coffee. Okay. Each orders either coffee or tea after dinner. If Appa orders coffee, let Appa is ordering coffee. Then Chappa orders the drink that Tappa orders. It will be same always. It means either it will be TT or it will be CC. Now the second thing, if Chappa orders coffee, it means this. Then Appa orders a drink that Tappa doesn't order. It means these two are ordering different drinks. So this case is not possible because in this case they both are ordering coffee. Now the third thing, if Tappa orders tea, then Appa orders a drink that Chappa orders. It means these two orders should be same, which is not so in this case. That's why this is rejected. So straightways we can say that Appa is always ordering tea. Is it okay, Amrita? Okay. Now Abhishek, your question, you said question number 2. That is again a concept of permutation combination. See, there are some lines. And you are making parallelogram out of those. These to make a parallelogram, I need 2 horizontal line and 2 slanting lines. There is a word called non-overlapping. First of all, I'm counting simple number of parallelograms. So in this case, it will be 4C2 into 3C2. That will be the total number of parallelograms. But in this case, we need non-overlapping. That's why how many parallelograms are possible? They are these shaded region only. So it will be 6 in this case. That is the answer. Yes, Abhishek. Are you okay with the figure? Now come to your question. I'll go by options. If I take 8, first option, it says the minimum number of straight lines required to obtain 16 non-overlapping parallelograms. You could assume that those parallelograms are square. If those parallelograms are squares, it means you need a chessboard of 16 squares. It means you need a 4 by 4 dimension chessboard. So to make a 4 by 4 dimension chessboard, you need 5 lines horizontal, 5 lines vertical. That's why what should be the answer? 10 should be the answer, not 8. Yes, Amrita, this is the answer. Is it okay, Abhishek? Because square is a parallelogram, you could take that example because you are comfortable in chessboard questions. Is it okay? Okay, guys. No, Shubham, we cannot say this. Overlapping is always area. We cannot talk about a line. We cannot take that these two squares are overlapping. They are not actually. But if I take the smaller one and the bigger one, they both are overlapping. Is it okay? Now, Amrita, coming to your doubt. Let my question be, how many zeros are there in 50 factorial? To make a 0 at the end, you need to know how many 10s are there. And to make a 10, you need how many 5s are there, how many 2s are there. Since 5 is a bigger prime, that's why number of 5s, that will be less. That's why we will calculate number of 5s. So how many 5s are there? What is the criteria? First of all, we will take 50 by 5, that is 10. Then again, we will take 10 by 5, that is 2. It means there are 12 5s in 50 factorial. Is it okay, Amrita? I'm considering that you know a little bit number system. Okay, that's it, guys. Okay, good. Okay, thank you so much. It was a nice session. Okay, see you next time. Thank you.